Alright guys, we're looking at 7C.3. I can identify whether trig ratios are equivalent by solving for missing side lengths using Pythagorean's theorem and properties of similar figures. So looking at example 6, which I'm not starting with example 6. Alright, we're given two similar triangles, triangle ACD and triangle ABE. So if we look here, ACD is going to be this big triangle, or if I go from A to C to D, then back, because triangles connect. Right? And then ABE is the blue triangle. Okay? So for the blue triangle, I have 3, 4, and I don't know that side, it's Y. For the red triangle, right, if I go from A all the way to D, I have 9 plus 3, which equals 12. This side is X. And then I have 15 plus Y. I don't know what this side is either. Okay. So I'm going to start by solving for X. So I'm going to do X over 12 equals, right, that's my red triangle. And then if I did X over 12, then I have to do 4 over 3. So then all I'm going to do is cross, right? I'm solving by cross multiplying. So I have 3 times X equals 4 times 12. 3x equals 4 times 12 is 48. I'm going to divide both sides by 3, and x equals 16. And that's it for solving for x. Now, looking for solving for y. To solve for y, I'm going to use something different. So there's multiple ways to do these types of problems. For this one, I'm going to use Pythagorean's theorem, right? I have this right triangle here where y is my c, right? So I have a squared plus b squared equals c squared. So a and b are 3 and 4. 3 squared is 9. 4 squared is 16. And then c squared, right, or we want to put in y squared. 9 plus 16 is 25. I'm going to take the square root, so y equals 5. I'm also going to put that 5 is here, right? So then I do know this longer, this whole side is 20. Alright, the last thing I have to do for this problem is the sine of angle ABE equals to the sine of angle ACD. Well, again, ABE is this smaller blue triangle. So again, I have my hypotenuse here, the opposite side, my adjacent side. We're still doing things with SOHCAHTOA. So sine of angle ABE so sine equals opposite over hypotenuse. My opposite side is 3 and my hypotenuse is 5. Then sine of angle ACD, if I go from A to C to D, that's this angle here. Again, I'm going to have my hypotenuse, my opposite side, and my adjacent side. So the sine of angle ACD equals opposite over hypotenuse. My opposite side is 12, and my hypotenuse is 20. I'm going to reduce those. Right. 12 over 20 does reduce to 3 over 5. So are these equal? I'm just going to say yes, they are. I could write for some reason. Yes. And that's it. All right, let's look at one more example with this. So again, example 7. Given two similar right triangles, we have ADE and triangle ABC. Use the diagram to answer parts A, B, and C. So again, we're going to start by solving for x. Again, I'm going to start by looking at my two triangles. So I have triangle ADE, my blue triangle, which has sides 5. I'm going to write over it. Come on. Eraser. Just on. Circle them. ADE, which is sides 5, 13, and then Y I don't know. Okay. And then triangle ABC is my red triangle. Alright, so X I don't know. This long side is just 24 plus Y. I don't know that. And then this side is 26 plus 13. Which equals 39. Okay. So I'm going to start by solving for x. So I know x over, I don't want to do down here, I don't know this side. So I'm going to do x over 39 equals, switch to my blue triangle. All right, to match with x is 5 over 13. Okay. I'm going to cross multiply. So I have 13 times x equals 39 times 5. Then 13x equals 39 times 5 is 195, I believe. Then last thing I'm going to do is divide by 13. So x equals 15. So that side is 15. Then for y, same thing. I can set up a proportion if I want. I could do like y over 24, 13 over 26. I could also do Pythagorean's theorem. So that's what I'm going to do. Okay, so again, if this is my right angle, this is my C. So then A and B. So if I'm doing A squared plus B squared equals C squared. Here I have 5 squared plus Y squared equals 13 squared. 5 squared is 25. 13 squared is 169. I'm going to subtract 25 from both sides. So y squared equals 169 minus 25 is 144. Alright, so the square root of that, y equals 12. So I'm also going to put a 12 in there. And then 24 plus 12 is 36. Alright, last part of this question, I'm going to move up a little bit, is the sine of angle ADE equal to the sine of angle ABC. So again, I want to start with ADE, this angle. So I know this is my hypotenuse, opposite, adjacent, right? So the sine of angle ADE equals opposite over hypotenuse. My opposite side is 12, and my hypotenuse is 13. Easy enough. Now, same thing for angle ABC. So the sine of angle ABC, A to B to C. Okay, this is my right angle. So I have my hypotenuse, my opposite side, and and my adjacent side. So my opposite side is, all right, opposite over hypotenuse. My opposite side is 36. My hypotenuse is 39. I have to reduce those still. 36 over 39 is 12 over 13. So then, are these equal? Yes. And remember, what's the point of showing that these are equal? All we're saying is these should be equal because we are told these are similar triangles. Okay, so we're kind of proving that these similar triangles have congruent trig ratios. That's it. Go ahead, work on your activity.